Okay, so we're going to go ahead and do the test 5 study guide. So the problems that Professor Karen told me to do for you guys are 1, 4, 5, 6, 10, 13, 16, 19, 22, 25, 28, 30, 33, and 37, 38, and 39. Okay, so let's go ahead and start with number 1. So number 1 says the function f of x equals 700 times 0.5 to the power of x over 9 models the amount in pounds of a particular radioactive material stored in a concrete vault, where x is the number of years since the material was put into the vault. Find the amount of radioactive material in the vault after 130 years. So this one is pretty straightforward. So since the x is number of years and it's giving us 130 years, we're just going to plug that into the equation. So you're going to have x of 1 or f of 130 equals 700 times 0.5. And so for this x, we're just going to plug in the 130. So you have 130 over 90. And then when you put that into the calculator, you get 257 pounds. And then that's the answer for number 1. Okay, so for number 4, it says find the accumulated value of an investment of $1,000 at 8% compounded continuously for 4 years. So because it's the accumulated value, we're going to use the A equals PERT formula. So first we're going to have to figure out what the P is. So the P is going to be 1,000 because that's the original value. So that's the P. The E is just the function E. The R is going to be the rate. So R is the 8%, and then T is time, so that's going to be the 4 years. So then we can go ahead and plug it in. So it's A equals P, which is 1,000, times E to the power of R, which is 8. But this 8%, you're going to have to divide it by 100 to get into a decimal. So it's going to be 0.08. So e to the power of 0.08 times t, which was 4. And then when you put that into your calculator, you are going to get A equals 1,377.13. And then that's your answer for number 4. Okay, so number 5 says find the accumulated value of an investment of $5,000 at 5% compounded monthly for 8 years. So because this one is going to be monthly, we are going to put it into the other formula. So we are going to put it into the A equals P parentheses 1 plus R over N to the power of NT. So first, let's go ahead and figure out what our P is going to be. So our P is going to be that initial value, so the 5,000. And then the R is the rate. So that R is going to be the 5%. And then N is going to be the amount of months. So T is the time, so that's going to be the 8 years. So the green T is 8 years, but that N is the amount of months it is. So for the N, that's 12 months because it's monthly. So then we just plug everything into the equation. So we have A equals P, which is the 5,000, times 1 plus R over N. So that R is that 5,000 or 5%, but we're going to have to turn that 5% into a decimal. So it's going to become 0.05. So that R is 0.05 over N, which is 12, to the power of N, which is 12 again, times T, which is the 8. And then you're going to go ahead and put everything into your calculator. And then when you do that, you are going to get $7,452.93. Okay, so now for number 6, it says log with the base 5 of x equals 2. So this one is just rearranging it. So you're going to have to remember that this down here, this 5 is going to be the base of it. So we're going to start with 5. And then not what's next to it goes on top, what's on the other side goes on top. So that's going to be this 2. So it's going to be 5 to the power of 2. And then all you have left is this x. So you're going to have equals x. So your final answer, you could probably leave it like that, but if you wanted to fully write it out, you would have 5 to the power of 2, which is 25. So you're going to have x equals 25. Okay, so number 10 says, evaluate the expression without using a calculator. And it says log with the base of 64, 4. So for this one, you're going to have to figure out how to turn 64 into 4. So we know that 4 to the power of 3 equals 64. So what this says is that 64 to the 1/3 power equals 4, which is also the equivalent of saying the cube root of 64 equals 4. So this 1/3 is the answer. So to rewrite it, you can say log with a base of 64 for 4 equals 1/3. Okay, so for number 13, it says find the domain in the logarithmic function. So for this one, you're going to have to remember that the domain means where the x can exist or where the function can exist. So we know that ln 0 does not exist and ln of a negative number does not exist. So that means that this 8 minus x has to be greater than 0. So you're going to have 8 minus x is greater than 0. So then you can subtract the 8 from both sides. So then you are going to get a negative x is greater than negative 8, which if you then multiply by a negative on both sides, you will get x, and then you have to flip the inequality symbol because you multiplied by a negative. So you get x is less than 8. So then you have to write it in the interval format. So because you would have to visualize it like a number line. So let's say we had 8 here. So the x is less than 8. So it'd be an open circle because it's not including it, everything going to the left. So that means it would be from negative infinity to 8. And the 8 is going to have a parentheses because it's not included if the inequality symbol had a line under it. So if it was less than or equal to, it would be a bracket, but it's not. So you have the parentheses indicating that it's not including 8, and then with an infinity symbol, you always have the parentheses, never a bracket. So for number 16, it says expand the logarithmic expression as much as possible. And 16 is log with the base of 11, 121 x to the power of 3 over z to the power of 4. So first you're going to have to remember your rules of logarithmics. So a log plus a log equals multiplication, and then a log minus a log is division. So let's first break up this part up here, the 121 and x to the power of 3. So you can rewrite that part as log 11 of 121 plus log 11 of x to the power of 3. And then because that is being divided by this z to the power of 4, that would be a minus log 11 z4. And then from there, you can simplify the log 11 of 121 because you know that 11 to the power of 2 equals 121. So from there, you get just 2. And then you would put this 3 up top of the x to the third in front of the log. So from there, you would get 2 plus 3 log 11, well, with a base of 11x. And then The same thing for the z, that 4 is going to go in front of the log. So then you get a minus 4 log with a base 11 z. And then that is your final answer for number 16. Okay, moving on to number 19. For 19, first we're going to go ahead and take this 1/2 and put it up top of that x. So then we're going to have a log with a base of 9, x to the power of 1/2. And then you can leave the log y by itself. So you have plus log with a base of 9, y. And then from there, you can change the x to the 1/2. X to the 1/2 is equivalent to the square root of x. So then you can simplify it like that. So then you have log 9 square root of x plus log 9 of y. And then here you're going to remember that addition means that it's multiplying. So this equals, you can turn it into 1 log by writing log with a base of 9 square root x times y. And then that would be your final answer for number 19. And then for number 22, number 22 says solve by expressing each side as a power of the same base. So first what we're going to have to do is we're going to have to look at this 9 and the 1 over 27. So we know that 3 to the power of 2 equals 9, and we know that 3 to the power of 3 equals 27, but to make that a 1 over 27, we're just going to add a negative sign. So it's 3 to the power of negative 3 equals 1 over 27. So then now that you have that, you can go ahead and express this. So for this 9, we're going to substitute 3 to the power of 2. So it's 3 to the power of 2, and then this, everything in the parentheses, so 3x plus 6. And then for the 1 over 27, we're going to express it as equals 3 to the negative 3rd. So then you can cancel out these 3's, and you'll be left with 2 parentheses 3x plus 6 equals negative 3. You're going to distribute this 2. That's going to give you 6x plus 12 equals negative 3. And then you're just going to solve for x. So you're going to subtract 12 on both sides. So you're going to get 6x equals negative 15. Then you're going to get x equals negative 15 over 6, which simplifies to x equals negative 5 over 2. And then that is going to be your final answer. So then we'll move on to number 25. So number 25 says, solve the exponential equation, express the solution set in terms of natural logarithms. So for 25, it is 3 to the power of 9x equals 2.3. So let's go ahead and write it as natural logs. And remember that a natural log is just ln. So we have ln 3 to the power of 9x equals ln 2.3. So then we're going to go ahead and take this 9x and put it in front of the ln. So then we are going to have 9x ln 3 equals ln 2.3. And then we're going to go ahead and divide both sides by ln 3. So what we're going to have now is 9x equals ln 2.3 over ln 3. And then we are going to divide both sides by 9. So what we are going to be left with is an x equals ln 2.3 and then a 9 over an 9 ln 3. And then that is your final answer for number 25. Okay, so moving on to number 28. It says solve the logarithmic equation. So you have log with a base of 6, x plus 4 equals a negative 2. So the first thing we're going to do is we're going to rewrite it. So remember that whatever the base on the bottom, so that 6 is going to be the base for the exponents. So it's going to be 6, and then whatever on the other side of the equal sign is going to be exponent for it, so that's going to be a -2. So it's x to the power of -2 equals whatever the log is, so equals x plus 4. So x to the power of -2 is 1 over 36 equals x plus 4. So then you have x equals 1 over 36 minus 4. So then you have x equals 1 over 36, and you're going to turn this into a fraction. So you're going to have minus 144 over 36. Where I got the 144 from is that what 4 times 36 equals 144. And then you're just going to subtract, and you're going to get negative 143 over 36. And then that is your final answer for 28. Okay, so then we are going to move on to 30. Okay, so for 30, it is also solving the logarithmic equation, but it is log with a base of 2, x minus 3, plus log base 2, x minus 9 equals 4. So first, let's combine our logs. So because we have this addition sign, we're just going to be multiplying what's on the inside. So we are going to have log with a base of 2. And then in parentheses, we are going to have x minus 3 times x minus 9, and then equal 4. So now we're going to get rid of the log by switching it to an exponent. So the base for the exponent is going to be 2. So we have 2, and then it's raised to whatever on the opposite side of the equal sign. So it's 4. So 2 to the power of 4 equals what's inside the log. So that is the x minus 3 and then x minus 9. So then from there, we're just going to factor everything on the right side and raise the 2. So 2 to the power of 4 is 16. So we have 16 equals, and then you're just going to factor the right side. So you have x squared minus 9x minus 3x plus 27. And then we can go ahead and combine like terms. So we are going to have 0 equals x squared minus 12x plus 11, which then you can refactor into 0 equals x minus 11 and x minus 1. And then x can't be 1. So your two values would be x equals 11 and x equals 1. But if you plug the 1 back into the equation, both of the logs will be negative, which can't happen. So that's not it. So after you plug it back in, you know that your final answer is x equals 11. Okay, and then 33 is also solve the logarithmic equation, and this time it is 2 log x minus log 4 equals log 169. So first thing we're going to do is that we are going to rewrite it. So we're going to put that 2 to the power for x. So we are going to have log x to the power of 2 minus log 4 equals log 169. So, and then we're going to combine the logs on the left side. So because of this negative sign, that means it's going to be a division. So that means we are going to have log of x squared over 4 equals log 169. So because now we have both a log on both sides with the same base, we can cancel them out. So then we are going to have x squared over 4 equals 169. And then we are going to multiply by 4 on both sides. So then we are going to get x squared equals 676. And then you're going to square root both sides. So you're going to get x equals plus or minus 26. But again, so that just means you have x equals 26 and an x equals a negative 26. But if you plug this negative 26 back into here, you get a negative number. So that one does not work. So your final answer is x equals 26. Okay, so then your next problem is going to be 37. So number 37 says the function a equals a0 e to the power of negative 0.0077x models the amount in pounds of a particular radioactive material stored in a concrete vault, where x is the number of years since the material was put into the vault. If 300 pounds of the material are placed in the vault, how much time will need to pass for only 175 pounds to remain? So the first thing we're going to do is we're going to go ahead and plug everything in that we need. So first we're going to have to find the A. So A is the final amount of whatever you're looking for. So that is the 175. And then A0 is the initial amount. So that's going to be the 300. And then what we're solving for is the X. So that doesn't have a value yet. So let's go ahead and plug it in. So A, which is 175, equals A0, which is 300, times e to the power of negative 0.0077, and then x is what we're finding for, or solving for. So first thing we're going to do is we're going to divide the 300 on both sides. So we are going to get 175 over 300 equals e to the power of negative 0.0077x. And then we're going to make we're going to add a natural log to everything. So then we are going to get ln 175 over 300. Let me rewrite that to be a little smaller. So then we are going to get an ln 175 over 300 equals, and then the ln and the e cancel each other out. So all we're going to have left is that negative 0.0077x. And then you're going to divide by the negative 0.0077 on both sides. And then if you put that into the calculator, so you'll have x equals ln 175 over 300 over negative 0.0077. Your final answer, and you put that all in the calculator, you have x equals 70 years as your final answer for number 37. Okay, so number 38 says the half-life of silicon 32 is 710 years. If 80 grams is present now, how much will be present in 70 years? Round your answer to 3 decimal places. Okay, so the first thing we're going to have to do is find the half-life equation. So the half-life equation is going to be A equals A naught e to the power of tk. So A is going to be the end amount, and then A naught is the original amount. So because we're just finding we're trying to solve for k. So because we're trying to find the half-life amount, we are going to make A 0.5, and then A naught is going to be 1. And the reason that it's going to be 1 and 1/2 is because it's just the easiest way to think about it. Okay, and then you're going to have e to the power of t. So the t we're going to use is the 710 years. And then k. So then you're just going to do a natural log on both sides. So then you're going to have ln 0.5 equals 710 k. So then you would divide both sides by 710. And then when you put everything on the left side into the calculator, the ln 0.5 over 710, you get k equals negative 0.000, negative 0.0000976. And then you're going to do another equation. So you're going to have another A equals A naught ETK. So now you're trying to find the final amount of A. So A is what we're solving for. So the first amount, so A0 is going to be the 80 grams because that's what we're starting with. So we're going to have A equals 80. And then the E to the power of T. So the T that we're now looking for is the 700 because now we're doing it for the second equation. So E to the power of 700. And now we do know K from what we did on the left side, which is the negative 0.000976. So then you're just going to go ahead and put all of that in the calculator to solve for A, and you're going to get A equals 40.393. And that will be your final answer for number 38. And then number 39 says, the logistic growth function f of t equals 760 over 1 plus 11.7 e to the power of negative 0.16 t, which describes the population of a species of butterflies t months after they are introduced to a non-threatening habitat. How many butterflies were initially introduced to the habitat? So the first thing you're going to want to look at for this one is the term initially. Initially is starting at the very, very beginning, so our t value is going to be equal to 0. So then once you know that, it's pretty straightforward. We're just going to be plugging everything in. So we are going to have f of 0 equals 760, and then 1 plus 11.7 e to the power of negative 0.16. And then our t value is going to be that 0. So then when you put the bottom part into your calculator, you are going to get 760 on the top still, and then 1 plus 11.7. So the E, because it's 0 times negative 0.16, which gives you 0. So you have e to the 0, and e to the 0 always equals 1. So that's why you have the 1 plus 11.7. And then when you put that into the calculator, you get about 60, which is the final answer for that problem.